Good morning. We're going to look at today the standard heat of formation, and this is a calculation question where you can use some values in the textbook that give you the standard heat of formation for a compound, and then you're going to look at a balanced chemical equation and then factor in your coefficients to calculate the overall enthalpy of a reaction. So on page 329 of your textbook, you'll have a table there that has a value for the amount of heat released or absorbed when 1 mole of the compound is formed from its elements at standard conditions. You'll notice that all the values in the textbook there are written such that they are formed from their elements, and you end up with a 1 mole coefficient because that's what standard heat of formation is. So they're all shown as a 1 molar compound, 1 mole of each of those compounds. Okay, you take the enthalpy of that standard heat of formation, and then you're going to factor it into a formula down below, which is really just an application of Hess's Law. So Hess's Law can simply be simplified using a summative method, whereby the standard heat of formation is used to calculate the enthalpy of an overall reaction. You take the sum of, and that's that little symbol there, you take the sum of the enthalpy of formation of the products, and you subtract that from the sum of the enthalpy of reaction of the reactants, okay? You'll notice that all of the standard heat of formation values are relative enthalpies based on the enthalpy of free elements that are arbitrarily assigned an enthalpy of 0 at standard temperature and pressure. For example, H2, so a diatomic gas, would simply be 0. That's just how it's arbitrarily assigned. So you may have a 0 value to factor in. So just be looking out for that when you do your sample calculations. Okay? All right, let's do an example. So the first one is, what would be the enthalpy of the reaction, the overall reaction for the complete combustion of propane? So step number 1, go ahead and balance the chemical equation. Okay, so you can pause the video if you'd like. All right, and so you should have your coefficients as 1, 5, 3, and 4. And so then your enthalpy of the reaction is going to be the sum of the standard heat of formations of the products and factor in your stoichiometry there. So if you've got 3 moles of carbon dioxide, can you see there where the 3 is going to factor in? Okay, so you're going to multiply the standard heat of formation of carbon dioxide that you take from the table, multiply that by 3, get the overall sum of the products, subtract the overall sum of the reactants, and you're going to end up with a final answer of negative 2,218.5 kilojoules per mole. And that's how you can use the standard enthalpy of formation and basically an application of Hess's Law. Okay, so this note actually, the top portion of this is something I've added into the notes. So I'll attach this as a PDF to the Google Classroom. So you can either just handwrite out the sample answer or you can print it if you'd like. And then the 2 sample questions that are at the bottom, question number 1 and question number 2, the solution sets are posted. The answers are here as well, actually, so you can just go ahead and calculate those. But you'll also see that these are the exact same questions as the ones at the top of page number 19. Okay, so that's it for today. Just a small little calculation using the standard heat of formation and an application of Hess's Law.